Hello class, today we're going to talk about section 9.2, which is solving quadratics by graphing. By the end of the lesson, you will be able to solve quadratics by graphing and estimate the solutions by graphing. When we are looking at the graph of a quadratic, we are looking for how many times the parabola touches the x-axis. So those x-intercepts are going to be our solutions, those x values that we can plug in. When we're saying solution, we are looking for when it hits 0. So what values of x make the y 0? In this first example, there are two solutions. The middle example has one solution, and the last example has no solution. So that is the number of times that the graph of the parabola hits the x-axis. So when we are starting this, we're going to use our skills from lesson 9.1, which was graphing using those characteristics. You can graph by table, but that's going to take a lot longer. So remember, our first job is to find our axis of symmetry. So we're going to take negative b, which is going to be positive 3, over 2 times our a value. In this case, we are going to get negative 1.5. Our next goal is to plug that back in to find the y coordinate. So I've got negative 1 times negative 1.5 squared minus 3 times negative 1.5 plus 18. Solving, I need to square 1.5 and then multiply by negative 1. So I'm going to end up with negative 2.5 there. And negative 3 times 1.5 is going to give us a positive 4.5 plus 18. Adding those all together, we end up with our answer of 20.25. So our point is going to be negative 1.5 and 20.25. That doesn't fit on the graph, so I'm going to go ahead and renumber, counting up by 2's. .25 is just slightly above that 20 mark, so I'm not going to need to extend it beyond that. And then our last point to figure out is that y-intercept. Remember, that is 0, comma, the c value. So in this case, we have 0, 18. I'm going to go ahead and put my first point on there, which is negative 1.5, and then up 20.25. And then I'm going to go ahead and put, put that y-intercept on at 0, 18. Symmetry gives me a point at negative 3, 18 as well. I'm going to go ahead and I'm going to connect those using my parabola shape. And then what I'm going to go ahead and do is I need to figure out where does that graph hit the x-axis. So we are looking at these 2 points. And my answers are going to be x is equal to negative 6 and x is equal to positive 3. So those are the 2 points where our parabola touches the x-axis. Go ahead and try this one on your own. Again, solving for x first, you're going to get positive 1. Plugging that back in, you're going to get negative 9. So your vertex is at 1, negative 9. Your y-intercept is at 0, negative 8. So we've got those 3 points down at the bottom. Your symmetry point is then going to be 2, negative 8. Drawing that parabola upwards, you end up with 4 and negative 2. Sometimes we have quadratics that are not set up for us to graph right away. We need to make sure all of our values are on one side of the equation. Per usual, you want to try and keep those x values positive when possible. If it's not, that'll be accounted for later when we solve for x and then solve for y. But it's easier to work with positive numbers instead of negatives. So I'm going to add that 2x squared to both sides, which is going to give me 2x squared plus 6x plus 6 is equal to y. Then I'm going to go ahead and find that axis of symmetry. So x is equal to negative 6 over 2 times 2, which is going to give me negative 1.5. Plugging that back in, I end up with y is equal to 2 times negative 1.5 squared plus 6 times negative 1.5 plus 6. Solving that, I'm going to end up with an answer of 4.5 minus 9 plus 6. Solving for that final answer, I end up with a y of 1.5. So my vertex is going to be at negative 1.5 and 1.5, coming over to the graph. Left 1.5 and then up 1.5 gives me my vertex. Then I'm going to go ahead and find that y-intercept, which is going to be 0, 6. Put that on my graph by going up to 0, 6. Using that symmetry, I'm going to mirror across and get a symmetry point of negative 3, 6. And completing that graph, we're now looking for where the graph touches the x-axis. As you can see, that graph never actually touches the x-axis, so this is a no real solutions parabola. It never touches, so we have no real solutions. Go ahead and try this one on your own. I added 8 and added 16 to the left side to keep those values positive. Finding our axis of symmetry, we get negative 4. Plugging that back in, we get an answer of 0 for y, so our vertex is at negative 4, 0. Our y-intercept is at 0, 16. As you can see, I renumbered up the side. Symmetry point is at negative 8, 16. And then when we are looking for that solution, we are looking for the one place that it hits the x-axis, and that is at x is equal to negative 4. The remainder of this lesson is covering the estimation, and we are going to be doing that in class in order to use graphing calculators to solve those problems. So stay tuned in class tomorrow for the final portion of this lesson.